All right, good morning. Today we are talking about complex numbers again. And we're going to talk about how to convert between rectangular complex numbers and polar complex numbers. Now, the good news is it's very similar to what we did before where we converted from rectangular to polar and vice versa. The only difference is how it is written. So if you look here, rectangular complex, if you don't remember, there's an x and a y value. The x is just by itself. The y value is part of the complex number. So like here, 2, that'd be like our x. The 5 is our y. And then for polar complex, the r is out front. And then when we write it, we have a cosine theta plus I sine theta. Okay, so we'll still just have an r and a theta. We'll just write it in this form instead of like the ordered pair. Okay, so let's go ahead. We'll use the same formulas that we've used before. We still need to think about which quadrants it's in, and these same formulas will work. It's just we got to write it in the different form. So first thing I want you guys to do, take a moment real quick and let's decide which quadrant each of these problems is in. So we've got 4 of them. If you want, you can pause it real quick. Just decide which quadrant will each of these be in. And what I mean by that is 2 plus 5. That's a positive, so it's somewhere up here. Okay, so that first one is Q1. Okay, the second one, Q2. The third one ends up in Q4. So it's positive, negative. And then the final one, they're both negative. That is Q3. And we'll use that as we get to the back. But for now, let's talk about how to convert these. So once again, this is in polar complex, and we want to go to rectangular complex. So the process is exactly the same. Just like before, we'll do the x and the y. So x equals 2 times the cosine of pi over 6. Okay. The y will equal 2 times the sine of pi over 6. So we look, what is the cosine of pi over 6? And that's the x value. So our x value, 2 over 1 times, it's square root of 3 over 2. Okay. Then for our y, it's 2 over 1 times 1/2, right? And so we'll see that we get the 2's will cancel. We'll get x to be square root of 3. Y will equal 1. Now, to write this, this is where it differs. Instead of putting it as an ordered pair, we're going to write it in complex form. So square root of 3 plus 1i. Okay? And that is all you have to do. So the next one, exact same process. This one, 3 pi over 4. So for our x value, it's going to be 4 times the cosine of 3 pi over 4. For the y value, it is 4 times the sine of 3 pi over 4. And for the x, cosine of 3 pi over 4, that's negative square root of 2 over 2. For the y, it's exactly the same, except it is positive square root of 2 over 2. And both of those will reduce to, well, this will be negative 2 square root of 2. This one will just be 2 square root of 2. Okay, so that's your x and your y. Your final answer then, negative 2 square root of 2 plus 2 square root of 2i. And that is how we write it in rectangular complex. For the last row, I'm going to skip 3. If you want to do it, the answer you should get is right here. But just to save a little time, for this last one, this one you'll notice is cosine of 3 pi over 2. So as you think about 3 pi over 2, that is straight down. So that will come into play. If you think about it, you might already be able to figure out what your x is going to be. But if you can't make that connection, just do the same process, right? Like before. And so for the y, we'll do the same thing, okay? And the cosine, so that's square root of 3 over 1 times 0. So we'll get a 0 for x. Meanwhile, our y, square root of 3 times a negative 1. And so y will be negative square root of 3. And we'll see then if we put that in complex, rectangular complex form, 0 minus square root of 3i. That is our answer. All right, so flip it to the back now, and we'll do the same process except going the other way now. So on the back, they give us a rectangular complex number, and we're trying to go to polar complex. So 1 plus square root of 3. If you look at this, we have our x and we have our y. So to find r squared, we know we are going to square the 1. Also, we're going to square the square root of 3. And this one comes out to 1 plus 3. R squared equals 4. When we combine it, that means R will equal 2. Okay? Now, just like we were doing on the front, if it's positive, that's somewhere up here. That's in Q1. So now we'll do our inverse tan. Remember, whenever we take our inverse tan, we always put the y on top. Or whenever we deal with tan, it's y over x. So that is just square root of 3. Where is tangent equal to square root of 3 in quadrant 1? If you don't know, pull out your unit circle, but that occurs at pi over 3. So now we need to write our answer. Remember, the 2 goes out front, then parentheses, cosine pi over 3 plus I sine of pi over 3. All right, and that would be our answer. So the process is exactly like what we did before. It's just you're writing it in complex form now. All right, once again, start it off, find your R. And here we get 25 plus 25. So R squared equals 50. That means R equals the square root of 50. Some of you might be able to do this by now and see that it was 25 and 25, so you might know the connection. If not, we can break it apart, right? I have a pair of 5s, right? So 5 square root of 2, that is what R equals. Now we go, and it was negative positive, so this one is in quadrant 2. So just remember that when you're doing our inverse tan. So now we're saying, where is the tangent equal to y over x? So 5 over negative 5. That simplifies to where is the tangent equal to negative 1. And it occurs at 2 spots, but one's in quadrant 2, one's in quadrant 4. We have to have the one in quadrant 2. So that occurs at 3 pi over 4. And so from here, we can write it out. So 5 square root of 2 cosine 3 pi over 4 plus I sine of 3 pi over 4. And when you type this into Delta, they have kind of a template. You're just filling in the blanks, so I think you'll be fine. Just make sure you have it in the correct form. So of our last two, we're just going to do one more. Let's do number 8. So if you choose to do 7, that's fine. If you want to check it, you should get 3 square root of 2 of cosine of pi over 4 plus I sine of pi over 4. If you don't feel like doing that, that's fine also. Okay. And the last one here, so for this one, for R, we know it'll be square root of 3 squared plus negative 1 squared. Okay. So this one, some of you might be able to do this without writing it all down, but if not, let's go through the process. We'll see R equals 2. Now for us, quadrant 4, because it was positive and then negative. So we know we're somewhere in quadrant 4, and we want to know where would tangent be equal to negative 1 over the square root of 3. Now on this, remember, square root of 3 on the bottom, rationalize. So we're saying where is it equal to negative square root of 3 over 3? And this will occur at 11 pi over 6, okay? Also occurs in quadrant 2, but we only care about this one. So we put the 2 out front, then cosine of 11 pi over 6 plus I sine of 11 pi over 6. So get this done. Tomorrow we will review, so if you have questions, you can ask questions tomorrow. We're mainly going to be reviewing on the different polar curves, but we definitely can talk about this too. Hope you guys have a great day, and I'll see you on Wednesday. Bye.